I wanted to put together a few ideas of what we perceive to be where the field is going. And mind that this comes out of monkey experiments. So not necessarily human, but that's where we're going. First thing, let me state the obvious. Human health crosses temporal and spatial scales. From milliseconds, what's going on inside cells, to millions of years, what happens at the evolutionary scale. We also have the physical domains of what happens inside a cell, the genome level, the interactions between proteins, metabolites, etc., to continental dynamics if we're going to look into epidemiology. We could even look into the influence of the moon in biological phenomena, because such thing actually happens. So we could consider this as a molecular astrobiology, and we wouldn't be too far away from the truth. So the first thing that I want to point is the tsunami of information that is coming, that is currently not part of clinical practice, but will become. And this is an example of recreational genomics, 23andMe. What 23andMe is telling, and I'm just putting here my own 23andMe ancestral tree, well, it's telling me where I'm coming from, and that's interesting. It's a conversation piece with the family and others. And by the way, I found a few sisters once it told me my genetic relatives, and I didn't know that. But it was very interesting. So it tells you that, of course, I'm, let's see, 1/4, 20-something% Native American, and 70% European. And of course, my ancestral mother is Native American, and my ancestral father is European, which matches the history of the American continent. They came to do their business, and that's what happened. But the left side is the interesting part. It's telling me that I can lose weight with any type of exercise. That's good, because I have the SNPs to do that, and any diet works for me, so etc. What is the certainty of these observations? Is low for most of the associations that we currently have, and could become stronger if we had a better way to link the data that is disseminated across many databases. And that's where the problem lies. For this tsunami of data, currently the National Institutes of Health in the United States fund 5 bioinformatics research centers, resource centers. So there is a database for mosquitoes, there is a database for genomes, there is a database for transcriptomes. A database for experiment does not currently exist. And that's a problem. Because if you want to conduct some machine learning exercise to test your powerful algorithm, you want to write a dissertation, give a pet project to a student, the first thing that you will have to do is, if you are not collaborating with biologists, go after the public data. But the public data is not coherent, is not entire. You might be missing something that only the PI has, because there is no database to deposit this additional information. The patient, the subject, the rat, the mouse had a flu infection at the same time that we were studying cancer, and that might influence the outcome. But if you do not have that information, it's not there. So the poster over there, and what we have been talking about is the fact that the state of the art forces many groups, independent groups, to work as jigsaw puzzle pieces. There is only one possible global configuration here. We want to go to the Lego block approach. What does it mean? That there are public databases with their own formats that are incompatible. If we want to aggregate data from multiple sources, we currently can do it with a lot of effort, and it's wasted effort that we have to repeat on every instance. And that is placing an obstacle in how deep can we go and how broad can we appreciate the relationships that are crossing temporal and spatial scales. Possible solution, data primitives. And of course, this is not the moment to talk about it, but it is there in the poster. Instead of dealing with many formats, instead of throwing countless resources, trying to harmonize heterogeneous data, we could build a dictionary to connect all the public databases. with a reduced set of these data primitives. The equation changes because then we would force algorithms and analytical engines to communicate with each other with these units of information. So you can imagine that, as we mentioned before, the tools, we saw one example today for matching entities, online tools will become increasingly available. We have a tremendously large constellation of resources now, and it will grow. So what do we need to do? We need to connect all those resources. We will need something like a resource allocation server, something that is a centralized resource that knows where the databases and the computational resources are, because we need to connect those two. We cannot simply use databases and forget about the computation that takes place, because, as we mentioned before, there are computations that are very specialized. They require a lot of effort. So that's where probably the biggest challenge for us is going to be in the coming years, for the foreseeable future, the integration of heterogeneous data and the aggregation of not only information, the aggregation of knowledge, those patterns that we can extract for information, many of which cannot be extracted just with machine learning. Okay, we keep talking.
Okay, Richard, you're on.
Okay. Peggy, can you put me on the slide for the top 6 challenges in healthcare data management?
Got it.
Okay. Here's 6 top challenges for healthcare delivery management. Components to the federal regulations, whatever they are. Healthcare systems. How do you handle the regulations when you have big data? The second one is mobile computing. You know, you have computer tablets, handheld devices to access patient records and make data entries directly. We need to have a secure network. In my teaching of my data mining class, we actually have SAS SAS Visual Analytics and SAS Visual Statistics to handle 1 million rows of data on tap on a mobile device, and this hadn't even thought about a couple of years ago. Sharing patient data, make sure you can have different systems or protocols, and you need to know how to integrate different medical data management systems, and that's an ongoing challenge. Number 4, lack of integration between clinical and administrative systems. You need to make sure that the data management system is configured, that the treatment codes match the care provided, it's accurately tracked for both administrative purposes and analytics. Next slide, thank you. Number 5, operational analytics. Hospital information system managers looking for new strategies to mine healthcare data to perform productivity and profitability and analytics to isolate profit centers and areas of practice that need to be reviewed and regard. Number 6, lack of analytics talent. With the area of big data, the healthcare providers are struggling to find analytical experts to help provide the technical expertise in big data. So we have all this new jargon with Apache, Hadoop, and so forth. And as I said in my teaching of my class for data mining, we use SAS Visual Analytics, SAS Visual Statistics, the Tableau. There's a whole new slew of software and technologies that people just need to be excellent. Peggy, next slide. So the top 10 challenges of big data analytics in healthcare include, number 1, data capture for big data. How do you capture the data? Number 2, data cleaning. You gotta have data that's clean, otherwise you can have inaccurate results. Number 3, data storage. How do you store big data? Number 4, data security for big data. Number 5, data steward to handle the development and creation of meaningful metadata for big data. You have to have some interface with metadata, data about data. Querying data involving data silos. You have immense amount of data in silos and so forth. How do you query the data? Reporting big data for healthcare. There's another way to generate reports from big data, but that's the challenge. Number 8, data visualization. There's an immense amount of techniques. I just finished my book on, half my book is on big data visualization techniques. And just learning, being up to date, being able to use the technologies for data visualization. Number 9, updating healthcare data. It's continuing, healthcare data is changing every day. Even while I'm giving this presentation, there's new data being generated and so forth. And, how do we keep up with this? Number 10, sharing data with external partners, that they may be compatible or incompatible technologies to what we have, especially when dealing with medical data around patients around the world. The next page, Peggy. What types of big data analytics that we have in business intelligence. So we need to be aware of prescriptive, predictive, diagnostic, and descriptive techniques for the data, healthcare, or anything else. So prescriptive, the type of analysis, what actions should be taken. Predictive, what actions might happen. Diagnostic, you might be working with a type of analytical dashboard. Descriptive, what's happening now, and typically what's going to happen in a real-time dashboard or email reports and so forth. And how do you mine that type of data using analytics? And the next slide shows real-time big data processing. Peggy, next slide. Yes? And so another challenge is it's real-time big data processing. And so with the new technologies that we have smartwatches, wearable devices to monitor millions of people with different types of diseases. How do you monitor that? Babies and specialists, premature and sick baby units, continuously adding data to that. How do we monitor and predict the development of epidemics and disease outbreaks using real-time processing and decoding DNA strings and so forth? So we have this, the challenge to keep up with this technology and how we get to monitor and analyze real-time data, big data. Next slide, thank you. Big data in healthcare, we have patient records, we have treatment plans, we have patient information. And so when it comes to healthcare, everything needs to be done quickly, accurately, in some cases, with enough transparency to satisfy stringent industry regulations. And so when big data is managed effectively, healthcare providers can uncover hidden insights that improve patient care. Peggy, next slide. And this is what I was talking about before when I was talking about the real-time processing big data, improving healthcare and public health. And as I said, number one, they're decoding entire DNA strings in minutes, allow us to find new cures and better understand predictive disease patterns. Number two, we have data from smartwatches and other wearable devices applied to millions of people in their various diseases. Clinical trials of the future won't be limited by small sample sizes, but could be potentially include everybody. Number three, big data techniques that have been used to monitor babies, especially with premature and sick baby units, by recording and analyzing every heartbeat, breathing pattern of every baby, they develop algorithms that can now predict infections 24 hours before the physical symptoms actually appear. That way the team can intervene early and save fragile babies in an environment where every hour counts. Number four, what's more, big data analytics allows us to monitor and predict development of epidemics and disease outbreaks. Integrating data from medical records with social media analytics enables us to monitor flu outbreaks in real time simply by listening to what people are saying, feeling about today and etc. Whatever. So, in a nutshell, those, many of the challenges that we're facing right now in big data analytics as applied to healthcare delivery. Peggy?
Thank you, Richard.
Yeah.
Okay, so here I'm kind of following up on what I started talking during my talk before. So we have been collaborating with social scientists, health policy experts, and especially when it comes to analyzing social data, but also this can be applied to other areas. There are some very common needs, and let's say as an example, I'm working with a professor from biology on how to study the impact of electronic cigarette as we see from the online forums. So what she wants is to collect data from the internet, then to extract disorders, symptoms, then to extract sentiment, and then to see, if there is something interesting, let's say, related to what flavors cause what, or what disorders are associated with electronic cigarette versus non-electronic cigarette, and so on. And similarly, I would do another project, let's say, with a psychologist on online bullying, and then it's kind of the same thing. We want to extract data from let's say from Facebook, and then classifies them if they're bullying or not bullying, have some people labeling it, and then visualizing and so on. So and also I'm working with this also with some other colleagues, and what we're working on now is to build data analysis as a service that has these capabilities. Let's say import data, filter data, label data, classify data, visualize and extract pattern, and then we have some loops to go back and modify and do it all over again. This is another scenario. Let's say a scientist, Mary, has a data set of 1 million geocoded Facebook posts, and she wants to find how many of them talk about diet, by male and female. So how to do it today? Today you can do it, but it's a lot of effort, and you need to use many systems and use an IT expert. So let's say you select the database system, and then you write your post on the database system. Then you to do the labeling. How we do it today is, let's say you pick a sample of 1,000 of them, put it in Excel, and maybe split it and give it to labelers, and by email the labelers will say this post is about diet, this is not about diet, and send it back to you. You collect everything. Then you have to check intercoder agreement. Maybe you have an Excel function or some other or a program to do it. Then you decide which coders are reliable, and you keep them. And then you get all this data, put it in, let's say, and try classifiers. You try, let's say, you try Weka, you try deep learning, play with the parameters, see what works best. And then in the end, you want to visualize it and try to manually extract some interesting things that you can, some observations. How it could be done if there is a nice tool for that. And I also have some mock-ups. This system doesn't exist, but this is like a mock-up of what could be done. Is, let's say you upload your CSV file, or you say I have a Twitter feed with these parameters, and then you see all the columns you have in your schema, and you select, let's say, which ones are of interest to you. And then maybe at this point you can visualize it, and also you can, let's say you want to label this data based on, let's say you define two classes, about diet, not about diet, in the middle. And then you say how much of the data you want to use as training, and how many, like say, how many overlapping, meaning how many of them you want to give, let's say if you can give the same data to 3 labelers, or you can give, let's say, start with some data and check the intercoder agreement. If the intercoder agreement is high, then you want to only continue, let's say, giving each post to only one labeler, so you can label more posts. Then you specify, let's say, the email of the labeler, and then every labeler will get an email, say, click here. So they start the labeling. As an admin, you can monitor their progress and check their intercoder agreement. And then when the labeling is done, you can click a button and say, now I want to build a classifier. And then the system will try many different classifiers and see which one works better. Once you're satisfied, then you can use this classifier to classify the rest of the data. And then you can visualize the data and see, let's say, what areas have more discussions about diet. You can see it on the map, let's say, with colors. And then you can go back and modify something. Let's say now I will select only the posts that are from the last 1 week, and I want to go through the whole pipeline again, and I want to visualize it. So it's kind of a trial and error. You try something, maybe there's nothing interesting, you change some parameters, you see there's something interesting until you find something, some interesting finding. And all this is a web-based interface, so you don't have to install anything. It's a service. And the idea is that for basic things that are common, you don't need to hire a programmer to help you, but you can do it yourself as a health or social scientist.
So here's my take on the challenges part of big data analytics in healthcare. So first is privacy and security. I think David has touched on that. And the second, the integration of different types of data. I think both of you have touched on that. So you have data in different formats, and there's no single standard. You basically have to aggregate them and integrate them together. And we also seen a talk on entity match on this subject. The third one, which is from my talk, is integration of different types of analytics together. So because application will usually require different types of analytics. And the fourth point is that we don't have enough people with big data skills, especially in the healthcare domain. I think Richard also touched on that. And the last point is we also don't have enough big data verticals on healthcare. Today, a lot of these big data analytics platforms are built for general business intelligence and not really have healthcare informatics in their mind. Even IBM Explorers is a kind of one example that works in this vertical, but I think we need more of those. In terms of future directions, I think we'll see more IoT data in healthcare and the use of them because of the wide use of fitness devices, sensors, monitoring devices. And the second one, I think you will see more personalized or patient-centric healthcare. So right now, for example, what I know is a lot of the hospitals they basically have a model for all the patients and to predict, for example, readmission into the hospital. Or they sometimes will divide the patients into demographic groups and then build a model per group. But I think in the future we'll see personalized models. You have one model per person. Because we have enough data for that. The third one will be preventive care, because there will be more predictive analytics, and you can predict whether this person is going to have, hypoglycemia events or something like that. That's all.
Panel, we have a microphone, so if you'd like to use it when answering questions. Does anyone have a question for the panel? We'll start with you, really loud.
I'm loud. So 2 or 3 of you mentioned privacy and security issues as being very high on the list of challenges. Does anybody have a great solution? How are you making it easy for data scientists to work with highly sensitive data sets?
I'll start if that's okay. Is this on? Can you hear me okay?
Yeah.
Okay. I don't have a great solution, but I can tell you what we're doing in that direction. So there are 3 things that we're doing. One is, one that we've done so far is to put agreements in place and operate with de-identified data. And there are a couple of different models we've used. One is where the data holder sets up the computational resources, a server, and we or whoever brings the machine learning analytics algorithms upload our algorithms there, do all the runs there, and bring things back. And we think that model works, except where you need more computational resources. So we've developed some new de-identification techniques. Really, Marshfield has developed a lot of these, including de-identifying everything. So even diagnosis codes get mapped to new numbers and so forth. And that helps. Having agreements in place helps. But we also need better technological solutions for really several reasons. So we're working on cryptography-based approaches, and as others are, and differential privacy-based approaches. The problem with differential privacy is you're adding noise to the data, and we find that unless you're getting into the millions of patients, that noise really tanks your accuracy. The problem with cryptographic methods is really the high runtime, and but I think there's a sweet spot now with the techniques that are available, maybe short of fully homomorphic encryption, but some other approaches that potentially can be used. But as you say, it's a huge barrier because, number one, you'd like to bring data together not from one site but from a dozen different sites, and so the model we're using now just doesn't work. And number two, there are lots of people every year with new improved algorithms who don't have access to this data at all. Differential privacy, again, gives a possible approach where you could create synthetic data that's not too much based on any one patient. And I personally would love to see the precision medicine initiative grow to the point where it serves as a vetted clearinghouse where people can apply to get access to large data set. These are some of the possible solutions, but they're far from perfect.
So I'm going to say something about, I think I showed the IBM Explorers platform. So what they do is they integrate the data from different sources and different formats, and then they output them into the data lake, and then they do de-identification. And I think what they had is basically a service, a big data service that is HIPAA enabled, and they provide APIs for different hospitals or different clients, and then they basically access the data through that API. I think that kind of protects the privacy of the user a little bit.
And one of the big challenges that are emerging with privacy is that each one of you, myself, we have metabolic profiles, transcriptional profiles, and if we try to mask those profiles, we're actually making a deep analysis impossible. So making and using the data is essentially using the fingerprint of the person, and the problem is just there. I don't have a solution. Perhaps the solution would be legislation to prevent the misuse of this data, because there is a point in which if we try to de-identify at this very low level, we start losing information.
Well, my solution to that was that I switched to online social networks because they were I didn't have to, because I was really very frustrated by going through the IRB process, and it was taking years, and then the medical collaborators also were losing interest because it was so slow. So then then at that point, so there is so much health related data that is not HIPAA constrained, which is data that you can get on the internet, or data that patients provide directly to you. Not everything is HIPAA, right? So if you have an app and people use it, you can analyze the data, and this is not HIPAA constrained. So that was my solution.
Yes.
If I may, since my question was stolen, but we can actually dig maybe a bit deeper into that. And in relation also to the other problems that you mentioned, some of them are not unique to healthcare, and there is always the tendency in healthcare to think that everything in healthcare, but if we can learn from other industry, maybe we can find solutions for, in this case, in the privacy issue, banking industry have similar challenges, and now on the horizon are shared ledger, like the Bitcoin type of solutions. So there may be technological solutions on the horizon, maybe decentralizing healthcare databases. Maybe actually the solution is actually in decentralizing and using other platforms to connect many users between each other without a center that is always the center of a tech is the center.
These issues go way beyond healthcare.
All right, the comment was made that privacy issues go way beyond healthcare. Are there any additional questions at this time? Yes.
So maybe, it's just to pick your brain on what you guys think about this. But if you look at like technological development in general, we always create a problem first and then think about a solution later. Be it like security. We pull all the data out and then think about security later. We create, we come up with sources of energy, or producing energy, and then think about global warming later. So my question is, in the realm of big data, we are at the early beginning phases, right? So are we creating any sustainability issues for the future, for that we would worry about 100 years from now, or maybe 10 years from now?
Okay, the question once again was, are we creating sustainability issues for the future to maintain all of this?
I would say something related to big data. I think it's related to healthcare, but also related to other things. So big data really started like maybe early 2000s, and people start to jump onto it, and it becomes such a hype. And I think one of the attractions for big data is now these tools can work directly on raw data. So you can dump data to this big shared storage, and you can query it. And so that came in this concept of data lake. But then the problem is that people start to dump data on it. But then there's a lack of tools to actually keep track of what data is where, and how to actually access the data. So now there's people also saying the data lake becomes somewhat a data swamp or something like that. So that's so. As I said, is there's this technology enabled something and people started to using it. Then later you realize that there's problems and you need to solve.
So I don't have a sustainability issue to talk about, but I think there is at least one big potential issue we should be thinking about now, which is as we start building these predictive models, and and we're working on these too, but we have to think very carefully about how and when we put those out, because people are going to use those and they're going to say, gee, if I put in this data instead, my risk goes down, and they're going to make wrong causal inferences about their health from these kinds of models. And so we need to think very carefully about how we give these models to the users, whether those are patients or clinicians. With clinicians, the FDA would certainly be involved, and there would be clinical trials, but even before a model goes to clinical trial, we owe it to those patients in the trial to do everything we can to get all the signal that we can out of the observational data, the retrospective data, and be confident that we're going to be doing good rather than harm for those patients.
The first reference to big data in the literature is from year 1814. That's Laplace's Treatise on Probability. This has been quoted sometimes as, give me the position and velocity of every particle in the universe and I will be able to predict the future. He said that in a full paragraph. It was a lot more flourished, but that's essentially the idea. He couldn't, of course, anticipate all the problems that we're having today, almost 2 centuries later. My point is not that we think about the problems when we do these things, but the problems emerge when we start using these technologies. So in many cases, it's difficult to anticipate what is the sustainability problem that we're creating, but there are problems that are emerging already, and we can comment on those. And one of the biggest problems that is emerging for everybody is that molecular techniques, if you don't use them yourselves, could be your cousin, could be the second cousin, identifies you immediately. So there is a network of relationships that can be built in the same way that we build relationships in social networks with clinical data. And I'm not talking in the traditional sense, I'm talking the future, not the traditional sense of your glucose level is X and your A1C is Y. No, you have these SNPs, you have these particular patterns in certain protein. That's the type of thing that are going to become available and will affect you whether you want it or not. That's a real problem, and it goes to what do we allow people to do with this data. One of the biggest fears is insurance. That insurance could use this information to increase the premiums on certain users. Some solution in that regard was provided by certain health law that now wants to be destroyed. So we don't know what's going to happen, but that's certainly something that is going to affect all of us, and not only in the developed world where the legislation is strong. There are very large data sets that have been collected from around the world where legislations are a lot weaker, and there is essentially nothing protecting this data. Last comment. In the treatment of tertiary syphilis until the 40s was done with malaria. people would be infected with malaria because the high fever would cook the pathogen for tertiary syphilis, and if they survive malaria, then they would be cured of syphilis. The records from the 1940s are still available. None of the people who provided the samples or wrote the records are alive today, but we keep using that information. So all the information that we will collecting today, even with informed consent or informed assent, might not cover all the uses that we'll receive. And that's something that we are not paying a lot of attention to, and that will also might create potentially a discriminatory problem for future generations.
We're out of time, or?
One more.
My comment would be is about regarding sustainability. Maybe I have a feeling that we're wasting a lot of resources because people, just have now this attitude that I will throw as much data as possible to the problem. So let's say you have a problem and you say, I will, try to add terabytes of data to the system, and then it will find the best solution. But most of the data is not useful. So instead of, let's say, suppose you have a data set of 10 terabytes of tweets and you want to do some analysis. If you do some simple things like removing retweets, removing the ones that have, let's say, hyperlinks, removing the ones that don't contain a couple of keywords, you will go from 10 terabytes to 10 gigabytes, because this is in reality how much you need for your problem. But people now say, oh, the more data the better, and we waste cycles of machines and energy and so on, just for nothing.
Thank you, panel members, for your perspectives on the challenges and future directions of big data analytics in healthcare. I'd also like to thank our keynotes and the paper presenters and the poster presenters, and also you for attending our workshop. We're glad that you came. We hope you've learned something today, and hopefully if you hear about us next year, you'll come back. Thank you.